Similar type of question here in example 2. We do need to get the root isolated by itself. Slightly more involved process because it's n minus root 5 minus n and not just a number. It will complicate things a little bit, but not too much. Need to move the n over. We'll subtract n from both sides. And we get negative root 5 minus n equals negative 7 minus n. Now we can't go ahead and square both sides yet because we have a negative attached to that root. Easiest way to deal with that is to divide everything by negative 1. Leaves us with root of 5 minus n equals 7 plus n. Now we can square both sides. Cancels the root. We get 5 minus n on the left. Now on the right we can't just square 7 and square n to get 49 plus n squared. We do need to actually do what the exponent says and FOIL out the right side. So left side will still have 5 minus n. The right side, 7 times 7, 49. 7 times n plus 7n. Insides, n times 7, another plus 7n. Lasts, n times n, which would be n squared. Got some like terms on the right we can combine, so we have 5 minus n on the left equals, and I'm going to reorder this into a more typical order with the n squared first. We have 2 plus 7n's, which should give us plus 14n and plus 49. Now at this point we can see that we have an n squared, which is different than example 1. This is a quadratic equation, is what we get out of it, and we do need to make sure that we can solve it. We did a few methods of that back in Unit 3, factoring, completing the square, quadratic formula, but in order to do any of those, we do need to have a 0 on one side. So we need to move this 5, subtract 5 from both sides. We need to move the n, we'll add n to both sides. So we are left with 0 equals n squared. We end up with plus 15n and plus 44. Now at this point, hopefully we can factor it, as that's the easiest method to solve a quadratic equation. To do that, we would need two numbers that both multiply to 44 and also add to 15. 11 and 4 fit the bill, so we can factor that into n plus 11 and n plus 4. To finish solving this, we need to split off. N plus 11 equals 0, and n plus 4 equals 0. Solving for n, we get n equals negative 11 here, and n equals negative 4 here. We do need to check these and see if they work out. I'm just going to flip over to the next page to do that. So for the checks, just like before, we're going to plug those numbers in for n in this case, see if the left side works out to the right side. So we had n, which is negative 11, minus the square root of 5 minus n, so 5 minus negative 11. And we're going to see if that works out to negative 7. So working our way out, negative 11 minus 5 minus negative 11 is really 5 plus 11, which would be 16, just to skip that step. and the square root of 16 is 4. And we can see at this point the left side works out to negative 15, the right side is negative 7. So this is, as I said before, a consequence of the method. Sometimes we will get answers that don't work. So what we need to do is to actually say that n equals negative 11 doesn't work. The way we do that, single line through it, and we just say that we reject it. Now, just because we reject one doesn't mean that the other one is automatically a valid solution. We do still need to check it. Substitute in negative 4 in for n, just as we did with negative 11. So on the left, under the root, we have 5 minus negative 4, otherwise known as 5 plus 4, which would be 9. Square root of 9 is 3. And we can see at this point the left side is going to work out to negative 7 just as the right side does. So negative 4 is a good solution.